Okay. All right. Okay. So what we're going to do is like this is length and for mass it's m, time for its small t. Electric current is I, temperature is T, amount of substance is N, light intensity is phi. Now the SI units for length are meters, M, kilograms for mass, time for seconds, current is ampere, temperature is Kelvin, amount of substance is mole, and light intensity is candela, CD, like that. Okay. All right. Now, so okay. Then what happens is that we need to learn about the derived quantities, their formula, derived units, and base units. You can write this down if you want to, okay, rather quickly. Okay. So now, so for derived quantities, let's learn it a bit and then we'll start doing the questions. Hold on.
Sir, can I take a screenshot?
Yes, please. I just want everybody to understand that the same
Okay, sir.
PDF has been uploaded on Google Classroom. You go to the drive, you check the PDF, and you fill the PDF like what I'm teaching, and then you have to submit that back once the topic is finished. It's very important. I'm going to check everybody's work, so you should be very, very vigilant. And if you do it every day, with me, it will be finished. This is not an homework. Okay. Now, derived quantities. So first of all, let's talk about velocity, acceleration, area, volume, force. Instead of force, let's add density first. Density, force, and then add momentum, add pressure, then energy, work, power, charge, voltage, and we are also going to do resistance. Now, let's do velocity. So velocity's formula is, you can say, it's velocity is displacement over time. Acceleration is change in velocity over time. Area is length into length. You can take any area. Volume is area into length. Density is mass over volume. Force is F equals to ma. Momentum is P is equal to mv. Pressure is force over area, or you can use rho gh, whatever you like. Okay? Energy, you can use anything, half mv square or mgh, doesn't matter. Then for work, you can take force times displacement. Power is force times velocity. Charge is current into time, right? Power, work, energy. Okay. Anyway, voltage is energy per unit charge, and resistance is voltage over current. You can write this down in a bit, okay? Now, speaking of this, then from velocity, let's try and do this. So the derived units of velocity are same as the basic units. So it's meters per second, and base units are meters per second as well. All right. The acceleration is meters per second square, and base units are meters per second square as well. Area is meter square and meter square. Volume is meter cube, meter cube. Density is kg of because of the mass and divided by the volume because it will be kg per meter cube, and it is also the same. Notice that every unit that I'm writing right now in this section has to be the same as the units in this section. So you need to make sure that you check back if there's an odd unit that was not given in the basic list, then there's something you've done wrong. Okay. Now, so the force units are newtons. And now Newton is made up of mass and acceleration, which means mass is in kg, acceleration is meters per second square. So this is why the base units of Newton would be kg meters per second square. Is that clear, everybody? Ahmad, do you understand this? Yaya? Swed?
Yes.
Yes.
Okay. Now, so then what you're going to do is next up, acha, then momentum is Newton's second, and momentum is made up of mass and velocity. So we can write kg as mass, and velocity is meters per second. Then pressure, you can use any of these. It's up to you. So if you use force over area or rho gh, pressure is given in pascals. Okay, so pressure is pressure, force over area. Now force basic units are given right here, which means that we can write these units like kg meter second minus 2 and divided by area, so which is meter square. So basically it will be kg meter second, sorry, kg meter minus 1 second minus 2. Is that clear, everyone? Okay, Javeria, Dua, Ayan. Now energy. So energy is given by joules, and you can use any formulas. Half doesn't have any value. M is mass, so kg, and velocity has a square on it. So velocity is meters per second and the square, which makes it kg. Meter square second minus 2. Okay. Let me know if you have a question here. All right. All right, you can please write this down and see if something, you can solve it on your own as well and see something is troubling you or not. Okay. Now, so work is also in joules, and work is given by because it's in joules, so it will have the same units, and you can also use the formula like force and displacement. So force is kg meters second minus 2, and displacement is basically meters, so it will eventually be kg meter square second minus 2. So like that you can do that too. Joules would just have the same basic units as everything else. So power is in watts, and power is given in force and velocities. Force is kg meter second minus 2, right? Times velocity is meters per second, or you can write meters s minus 1. So this will become kg, meter square second minus 3. You can alternatively do energy over time. That will also give you the same thing. Okay. All right. Yaya and Hamad and Zahan, everything is clear?
Yeah.
Yes,
Good.
sir.
Now, going to charge then. Charge is current into time because current is in amperes. Sorry, it says charge has its own unit. My bad. Charge unit is coulombs, C, uh, because it has ampere and time. So it will be current is in ampere and time is in seconds. So it will be AS, right? Like that. And both ampere belongs to, you see, it belongs to electric current and it also belongs to time. So they're basic units. So you don't have to do anything else. It's pretty easy here. Speaking of voltage then, because voltage is energy over charge, voltage is in volts. So energy units were kg meter square second minus 2. So this was energy divided by charge in ampere seconds. So now you can, bring it up. It will be kg meter square ampere minus 1 and second minus 3. Please have a look at it and let me know. Okay. Now, resistance is in ohms, so it's ohms like this. And then because it's voltage over current. So voltage units are just, we just found out as kg meter square ampere minus 1 second minus 3. So you can divide it by current again, and then it is going to be kg meter square ampere minus 1, minus 2, in fact, and then second minus 3. All right. Suhail, Dua, everything is clear. Ayan, Hamad, Javeria, and Yaya.
Mhm.
Okay, very good. If you have any question, you can write this down. While solving this, try to solve it on your own. See if you can do this. And if you feel difficulty or anything, do let me know, okay? Okay. Now, should I go forward then? All right. When the meeting ends, please rejoin the same link. Okay. The class will end at 6. So make sure you do that. Anyway. Should I go on now? Everybody's written this?
So I finished.
Sorry, come again?
I have not finished.
Okay. Yeah, your mic is not really clear. I don't know what's the issue.
Sir, you are moving a little too fast.
Where do you want to, Zahan, where do you want to write something? Tell me.
Sir, I'm writing this down right now.
Okay, right. Just let me know when you.
Sir, I'm taking screenshot so I can complete it afterwards. So you can move forward.
No, no, you can write it down. It's fine. I just want to, it's solving this, you're writing it. Just see where you can't do this on your own. So that way you can, analyze yourself. Hello. Walaikum salam. Yes. Yes. Good, good. It will be 7 बजे properly. I don't know. Yeah. Okay. हम्म हम्म कर दो कर दो कर दो. All right. Now, done. Should I go forward now?
Yes.
Yes, sir.
Okay. Now, so now we're going to move towards the questions from the paper, because we're just going to, solve in this crash course. We're just going to focus on how the examiner is going to ask you the questions. So I've taken out the most difficult ones. We're going to do these, and then, it will be good for you. So first of all, it says two of the SI base quantities are mass and time. State three other SI base quantities. Um, can you please help me with this? Sorry?
Distance.
Distance? What is distance?
Length.
Distance on SI. Length. Okay. Length.
Temperature.
And what
Temperature,
else?
current.
Temperature. Very good. And current, right? So these questions will be there. So you get 3 marks right here. Then it says a sphere of radius r is moving at speed v. So we have speed given. Air density is given. The resistive force F is given. And it says where B and K are constants without units. State the SI base units of F, rho, and V. Now, F is force, rho is density, and V is velocity. So, all right, Hamad, can you tell me the SI base units of force?
Kilogram meters per second square.
Kilogram meters per second square. Correct. All right. Then comes Dua. Dua, can you please tell me about density? You can quickly, on the side, you can always find like mass over volume and then. Yes, Dua, hurry up, please.
kg per
Yeah.
meter.
Kg per meter cube. Okay, very good. And Yaya, can you please tell me the units of velocity?
Per second square.
Meters per second squared? Are you sure?
Yeah, just measure second.
Meters per second. Very good. That's very good. Okay. So now we've done this. Now it says determine the value of K from this. Okay. Now, first of all, what you need to do is always in the step 1, make sure to remove root, any root. It could be a square root or cube root or whatever, right? Now, so what you're going to do is next, always make the variable required your subject. So that's the second tip. Okay. And obviously then you have to, get the answer right. All right. Now, so we need this k in the equation. So what I'm going to do is I'm going to write f equals to b r square rho v and k. Now this is a difficult question, so I'll solve this and you can follow along. So to find k, I'm going to make wherever the k is the subject, so it's on v. So I'm going to put it here, and then on the other side, f times 1 upon b times 1 upon r squared. Notice that I write everything separately because I don't want uh, them to just make a cluster, and that really sometimes that's the only reason people make mistake in this. Write everything separately, and then what you're going to do is you're going to say put in the units. It says b and k have no units at all. Interesting, right? K is a value. So we're going to ignore the ones which have no units at all. So it's meter per second for the velocity, and it has a power of k. Force is kg, meter second minus 2. Because B has no units, we're going to ignore this. Writing no units. So ignore. All right. So please also write it in your PDF as well. So when you're revising everything, you can see what I've done here. Then what you're going to do is R is in meters because I believe R was the radius. So 1 upon meter square, and density is 1 upon kg meter minus 3. Then what you're going to do is from this point onwards, just simplify to remove negatives. All right. So what you're going to do is now you say m over s k equals to kg meter over second square. Just remove everything that has a negative sign. Meter cube will go up. So meter cube over kg, right? Okay, let me move it the other side. Let me move it here so we can solve it easily. Then simplify, keep simplifying it. So you get, there are 4 meters on top, as you can see, and there are 2 meters below. So kg will cancel out with kg. Now you're left with 4 meters on top and 2 down. So when they cancel out, so this will become only meter square and divided by only second is remaining, second square. You see what I've done? So I cancel out 4 meters from 2 meters down. The only thing remains is meter 2, and then we get second 2. Okay. Now, so we can write this as